This is the GCSE Further Maths paper, and this is the pure one. So this one's from June 2023. Let's take a wee look then at question 1. Find dy by dx if y equals 2/3 x to the 6 plus 2x to the power of 4. So our first move here is to rearrange this one. We don't like differentiating in this form. So I'm going to write y here. Remember, I'm not differentiating yet, so I'm still writing y. So it's 2 over 3 x to the power of 6 plus 1 over 2 x to the power of minus 4. So hopefully you can see what I've done there. I've brought that power x to the power of 4 up. So we have that. Now I'm ready to differentiate. So I'm going to subtract 1 from the power and multiply then by the whole power. So it's going to be 12 over 3. I'm going to subtract 1 from the power. Be careful with this. It goes into minus 5, and I'm going to multiply by the whole power. So it's going to give me minus 4 over 2. Those, of course, tidy up. So I get dy by dx equals 12 over 3, which is 4x to the power of 5 minus 2x to the power of minus 5. And if you want, you can bring that one then back down to the bottom. So dy by dx equals 4x to the power of 5 minus 2 over x to the power of 5. They will accept this answer though. Express y in terms of x if dy by dx equals this, given that y is 7 when x equals 2. Well, they've given us dy by dx and we want y, so in this scenario then we need to integrate, and so we're going to need to again bring this one back up to the top. Whenever we integrate, we'll get a c, and the 7 and the 2 here are used then to help us work out the c. So y is going to be the integral of 3x squared minus 4x to the minus 2 minus 4 dx. And so then integrating each of these terms, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and then the minus 4 of course becomes a minus 4x. And we remember plus c. So again, this will tidy up. The 3's cancel, so we get x cubed. The minus 4 and the minus 1, so the negatives cancel. So I get 4x to the minus 1, then minus 4x plus c. Again, I might want to rewrite this. In fact, in this situation I will. X cubed plus 4 over x minus 4x plus c. It's just handier to substitute numbers into this. It tells us that y is 7 when x is 2. So if I bring that then down into here, I'm going to get 7. 2 cubed is of course 8. 4 over 2 is 2 minus 8 plus c. If I rearrange that, I'm going to get c. It's 5. So my final answer then is this, with the c exchange then for a 5. So it gives us then the y down here. So y equals x cubed plus 4 over x minus 4x plus 5. On this page, sketch the graph of y equals cos x between minus 180 and 180 on the axis below. So we want to get a decent scale here. We should know that cos goes as high as 1 and as low as minus 1, and then if this is going to be 180, then this next one here is going to be 90. Hopefully you can see that in the video, that these are slightly heavier. And then these are our negatives here. Again, you can use your calculator for this. If you do cos of 0, you're going to get 1. If you do cos of 90, you're going to get 0. And if you do cos of 180, you're going to get -1. I think it's really wise to pick some numbers in between. Now, this is kind of cut up in a funny, different wee way here. So these are kind of split up into 5, so it's kind of 18 degrees. We don't like that. But maybe even, kind of cos of 30 or cos of 60 to kind of see the curve shape. Don't be just joining those up in a straight line. The same as in -90 would be here. And we have that. And it should give us a nice curve. You should be familiar with this curve. And so it should give us in a nice curve shape. It looks something like this. And we end up there with that. Solve the equation 3 cos x equals -2. So we need to rearrange this first of all. So it's cos x is then -2/3. And the way I do it, I'm going to find the basic angle. And by find the basic angle, I'm going to ignore the negative. So I'm going to write x equals cos to the -1 2/3. Let me get my calculator here. Just going to pause because I need to change a few things. So cos to the -1 of 2/3. And that's going to give me 48.189. Sorry, 1897. And now I'm going to do my cast diagram. Again, people do it different ways. It's okay, that's C, that's A, that's S, that's T. Because we're between -180 and 180, I'm going to go 0, 90, 180, and then 0, -90, -180, and my basic angle then appears here. Now I want where cos is negative. Cos is positive in this quadrant and this quadrant, so I actually want this one here, and I want this one here. So I need to find this angle here. Now, using symmetry, I know that's 48.1897, so that's 48.1897. So I need to then take that away from 180. Just do it on my calculator now, and I get 131.81. So one of my answers is 131.81, and the other one then is a negative version of that. So -131.81. So my two answers are 131.81 and -131.81. Hence, solve the equation 3 cos theta over 2 minus 10 equals -2 for -360 at 360. I keep telling my classes here that this doesn't involve any trigonometry. The hence means working out what you've used before, and when this here was our x in the question before, it's just the same question. Hope you can see that. 3 cos x equals -2, 3 cos this equals -2. So I'm going to let my 131.81, which you remember from the first one, equal this, and my minus 131.81, and just work out my value for theta. So theta over 2 minus 10 is 131.81. That means theta over 2 is 141.81. And then theta, we're going to times that by 2. And that gives me 283.62. The next one I need to do exactly the same. Theta over 2 minus 10 and set it equal to the other one, so it's minus 131.81. Careful here, obviously, if you're adding 10 to both sides. That then gives me minus 121.81. Timesing that then by 2. Gives me minus 243.62. And so those then are my two answers to this. So it's going to be 283.62 and minus 243.62. Question 4. A function f of x is defined by f of x equals x squared minus 8x plus 24. Use a method of completing the square to rewrite it in this form here where a and b are constants. So we have x squared minus 8x plus 24, and the way we set it up is I take half of this here. So then over to the side I'm going to multiply out x minus 4 all squared. That's x minus 4 upon x minus 4, and that gives me x squared, outer and inner is minus 8x plus 16. That means this generates a 16 that we do not want. So after this gives us x squared minus 8x plus 16. So we take away our 16 and then we add our 24. So that gives us then x minus 4 all squared plus 8. So my answer to this one then is x minus 4 all squared plus 8. Hence, write down the coordinates of the minimum turning point of the curve x squared minus 8x plus 24. So I can write that then as y equals x minus 4 all squared plus 24. So the lowest this can go is 24, and that happens whenever x is 4. So there's a minimum when x equals 4, and that gives me y is 24. Sorry, I knew there was something wrong there. That's not a 24, of course, that's an 8. Look at the end of the question there. We have an 8 here. That's plus 8, and y equals 8. So the minimum point then is the coordinate 4, 8. Question 5. A rectangle has width x and length 6x plus 5. Find the range of values for x for which the area of the rectangle is less than 6 centimeters squared. You must show clearly each stage of your solution. X then multiplied by 6x plus 5 is going to equal, is going to be less than 6. So that means 6x squared plus 5x has to be less than 6, and this is turned into an inequality question. 6x squared plus 5x minus 6 is going to be less than 0. So we're going to then solve, we'll find our critical values here, and so we're going to solve this quadratic. 6x squared plus 5x minus 6 equals 0. People have lots of different ways of solving quadratics. This calculator, of course, will do it for you. It will actually solve the inequality as well. But solving this, you can do it whatever way you want. I'm not going to do it now for you. But it gives you 3x minus 2, 2x plus 3. Hopefully you're familiar enough with that. That gives me x is 2/3. Or x is minus 3 over 2. So this here, if we get an idea then of the sketch of y equals 6x squared plus 5x minus 6. There are other methods here. Some people like to use a wee table with pluses and minuses, but it crosses, it's a U shape because it's a positive x squared. It crosses at 2/3 and it crosses at minus 3 over 2. And we're looking for where this line is below, is it less than 0? So where is this less than 0? It means where this line is lower than our x-axis, and that then is in between here and here. So that means our value of x is in between minus 3 over 2 and 2/3. Now, because this is a practical question, you can't have a value of x, you can't have a width of a rectangle, otherwise it's a negative, so we need to then kind of reconfigure that. So our answer then is going to be 0 as an x, simply because it's a practical question. 2/3. Again, your calculator will sort this out for you. You can't just use the calculator, though it will give you this answer here just kind of straight off if you input those values, but you can't just use that. You need to show your working. It says you must show clearly each stage of your solution. Matrices A, B and C are defined by those. Solve the matrix AX equals C. So we are going to have to find the inverse of A. So we have some matrix X and it's going to equal that. So we're going to need to find the inverse then of A. So A to the minus 1 is first of all going to have to find the determinant. So it's minus 15 minus 8. So it's going to be then minus 7. So it's going to be 1 over minus 7. And I change around these two. And I change the signs of these two. And so then X, we can have AX equals C. And then A to the minus 1 A of X is equal to A to the minus 1 of C. And so X equals A to the minus 1 times C. So my A to the minus 1 I need to times by C, and that should give me my answer. So X then equals minus 1 over 7, minus 3, 2, minus 4, 5, minus 2, 5. This is a 2 by 2. This is a 2 by 1. So we can multiply them. And the result then is a 2 by 1. So we're looking for something like that. Minus 3 times minus 2 is 6. Plus 10. That gives me 16. And then minus 8. Sorry, 8. Minus 4 times minus 2 is 8. And 25. That gives me then 33. So my answer then is, well, you can do it whatever way you want. You could go minus 16 over 7 and minus 33 over 7, or you could just leave the 7th sitting out there. Explain why it is impossible to solve the equation bx equals c. Well, I don't know, so let's take a wee look at b. So what would we have to do? We'd have to find the inverse of b. So let's look to find the inverse of b. So first of all, we'd be finding the determinant. 3 times 2, take away 1 times 6. So because the determinant equals 0, then you can't have an inverse. Determinant of b equals 0, therefore it's no inverse. Okay. Log to the base 7 of 3 is a, and log to the base 7 of 2 is b. Express log to the base 7 of 10.5 in terms of a and b. Well, we need to be able to make 10.5 out of 3 and 2 and actually 7, because if we know our laws of logs, we know log to the base 7 of 7 is of course 1. So how am I going to make 10.5? It's kind of a slightly awkward number here. It's like 1.5 sevens. So how am I going to get 1.5 sevens? If I times a 7 by 3, that's going to give me 21, and then divide by 2. So log to the base 7 of 10.5 equals log to the base 7 of 3 times 7 all over 2. Using our laws of logs, that's the same as log to the base 7 of 3 plus log to the base 7 of 7, take away log to the base 7 of 2. Log to the base 7 of 3 is a. Log to the base 7 of 7 is 1. And then minus b. So my answer is then a plus 1 minus b. solve the equation. This is obviously then an index equation, so we're going to have to take logs in of both sides. So log 9 2/5 x minus 2, quite an awkward wee number here, equals log of 4. There's a couple of different ways of doing this one, but we're going to bring this power then to the front. So 2/5 x minus 2 log 9 equals log 4. Now quite often here you would multiply this out, but you can in this scenario divide by log 4, then add 2, and then kind of times by 5 over 2. I'm just going to multiply it out because we're quite used to that. So it's 2/5 x log 9 minus 2 log 9 equals log 4. This is a complicated looking thing, but it's effectively just like a second form algebra thing, just with slightly more awkward numbers. 2 log 9 is just a number, log 4 is just a number. Anything with an x I'm keeping here, anything with an x I'm moving to the other side. So it's 2/5 x log 9 equals log 4 plus 2 log 9. And then I'm going to get x is log 4 plus 2 log 9 all over 2/5 log 9. I don't really love having a fraction within the fraction there, so you get times through by 5 if you want, which kind of then be your top line, but you can stick that into your calculator anyway. If you put that all into your calculator, you'll get an answer then of 6.58. And that's our answer then to that one. Matrices A, B and C are defined by this, and this. Calculate AB. So that's going to be 4, 3 upon 3 minus 1. So just need to be careful here. This is a 2 by 1 and that's a 1 by 2. I can multiply them and the result then is a 2 by 2. So that's going to then be 12. That's a 4 times 3. 4 times minus 1 is minus 4. 3 times 3 is 9. 3 times minus 1 is minus 3. So my answer to this then is 12 minus 4, 9 minus 3. C squared minus AB. Well, first of all I need C squared. Remember, you just can't square each term here. We need to do some multiplication. 1 plus 6, that gives me 7, minus 2 plus 8, that gives me 6, minus 3 plus 12, that gives 9, and then 6 and 16, that gives me then 22, and then AB, well, we've worked out AB, so it's going to be C squared minus AB. It's going to be 7, 6, 9, 22. Take away AB, we've just worked out to be 12 minus 4, 9 minus 3. And subtracting is nice and straightforward, we hope. 7 take away 12 is minus 5. 6 minus minus 4 is 10. 9 minus 9 is 0. 22 minus minus 3 then is 25. So that's the answer I'm looking for. So minus 5, 10, 0 and 25. So let me just tidying up here. On to question 9. Simplify fully the following algebraic expression. We have this, so we have kind of this thing here. I'm going to find the common denominator here and tidy this thing in the bracket up. I'm then going to divide by this fraction, so I'm actually going to turn this one upside down. So how are we going to tidy this? I'm going to multiply top and bottom of this one by x. So my first bracket then is going to be x squared over 2x, and top and bottom of this one by 2, 4 over 2x, and multiplied by 6x over x plus 2. Hope we're good with that for a first move. We have same denominator here on the bottom, so that's going to be x squared minus 4 all over 2x multiplied by 6x over x plus 2. And then we're looking to cancel out common factors. So there's an x is going to go there, there's a 2 is going to go there, and you spot this is different to 2 squares. So that's going to be x plus 2 upon x minus 2. all over 2x multiplied by 6x and x plus 2. So we're now in a decent place to cancel out our factors. X plus 2 and the x plus 2 are going to cancel out. That x minus 2 is left. That 2x is going to go, and we end up then with a 3 here. So we have a 3 upon x minus 2 then as our final answer. And that's us. Question 10. A curve is defined by the equation y equals 2x cubed minus 3x squared plus x plus 5. Find the equation of the normal to the curve at the point minus 1, minus 1. So we're finding the equation here of a normal. That's a straight line. So it's going to be y equals mx plus c. We need to find the gradient, and we need to find the y-intercept. That's the m and the c. So if we find the gradient, we're of course going to differentiate. So first of all then, dy by dx. That gives me 6x squared minus 6x plus 1, and I'm trying to find the gradient then whenever x is minus 1. Minus 1 squared, so that just gives me 6 plus 6 plus 1, and that gives me 13. Therefore then the gradient of the normal is going to be the negative reciprocal of that. So that's going to be minus 1 over 13. It's not a lovely equation to have, but that's okay. So we have y equals minus 1 over 13x plus c. I hope you're happy with what I've done there. It's y equals mx plus c. I know the gradient of the normal is minus 1 over 13, so we have that. And to find the c, I'm going to substitute in the point minus 1, minus 1. So at minus 1, I get minus 1. And then this times minus 1, so that gives me a 13th plus c. If I take away 13th from both sides, I get minus 14 over 13 then equals c. I hope that's okay, because that's a minus 13 over 13, and then they were taking away another one. So my final equation then is y equals minus 1 over 13x minus 14 over 13, and that'll get you full marks. The other way we can do is kind of rearrange that if you want. You get times through by 13 to get rid of all the fractions, but I'm happy enough with it like that. On to question 11. This looks to me like it's going to be our 3 equations, 3 unknowns. Let's see how we go. Jack, Jill and Jared individually deposited money in each of 3 banks, A, B and C. Bank A pays X interest per year, B pays Y and C pays Z. Jack deposited 1,500, 3,500, 4,500 in the banks A, B and C, and received 305 overall interest. So we need to find then our equation for that. So if x is a percentage, say for example it was 5%, and we had to find 5% of that, we'd multiply by 5 over 100. So we're going to multiply by x over 100, y over 100, z over 100, and that should then give us the 305. So it's going to be 1,500 x over 100, quite messy this, plus 3,500 y over 100 plus 4,500 z over 100, and that equals 305. So that cancels down then to give me 15x plus 35y plus 45z is 305. And if you know your 5 times tables, then we're going to divide that by 5. That's going to give me 3x plus 7y plus 9z, and no prizes for guessing. We get then 61 here. So that's our first one worked out. Jill deposited 1,000, 2,000 and 6,000. So again similar. So it's going to be 1,000x over 100 plus 2,000 y over 100 plus 6,000 z over 100, and she got 330. So I'm going to then cancel this down. So again it's 10x plus 20 y plus 60 z is 330, and of course this one then divides by 10. So we get x plus y, sorry, plus 2y plus 6z is 33. So we're good for our second one. Jared deposited then. Again, it's similar enough. I haven't changed anything here for this last one. So 2000x over 100 plus 3000x over 100 plus 5000x over 100, and he gets 320. Similar then, so it's going to be 20x plus 30. Spelled my mistake here, sorry. That's obviously y, and that one's z. 30y plus 50z is 320, and again, if we divide those by 10, we get 2x plus 3y plus 5z is 32. Solve the equations below to find the percentage interest per year paid by each of the banks, showing clearly each stage of your working. I think it makes so much sense if we eliminate the x's here from this. So again, just to show the examiner what I'm doing, I'm numbering these 1, 2 and 3, and let's see what I'll do. I think I'll go for if I go 3 times this one and then kind of take away this one, so 3 times number 2 is going to be 3x plus 6y plus 12z is 99, and then number 1 is 3x plus 7y plus 9z is 61, and if I subtract those, I think I get then minus y plus, what do I get? Have I done this correctly? Oh, that's an 18, sorry. 9z, and then taking those away, I get 38, so I'm going to call that then equation 4. So now I'm going to times this one by 2 again, so it's going to be 2 times by 2, that gives me 2x plus 4y plus 12z is 66, and then equation 3, which you can just see here then, is 2x plus 3y plus 5z is 32, and take those away, then I get y plus 7z then. I take those away and I get 34, and that's equation 5. This is going to work out nicely enough because of minus y here and a positive y here. So if I just add those two together, so if I write my 4 here, minus y plus 9z, sorry about the z, is 38, and if I add those two together, I get 16z. Hopefully it gives me something nice. Add those together, I get 72. Okay, so it's not awful. So my z then is 4.5. If I substitute that into number 5, I get y plus 7.4.5 is 34. Y plus 31.5, 34, so y then is 2.5. Where are we for space here? Pretty good. We should be able to fit it in this one page here, and then substitute these two probably into equation 2, I would say, and then sub into number 2. So we have x plus 2y plus 6z is 33, x plus 2y's is 5, 6 4.5's I think is going to give me the 27 is 33, 5 plus 27 then is 32, so x then is going to be 1. So we can put our answers in here. So bank A paid 1%, bank B paid 2.5%, and bank C paid 4.5%. That is us for question 11. We're doing well. Question 12. A curve is defined by the equation 2x minus 1 upon x minus 2 all squared. Write down the coordinates of the points where the curve meets the x-axis. So we know the curve meets the x-axis. We're effectively slowly but surely going to work out where these things where they kind of cross the axis. When I find turning points, probably and plot it, is my guess for this question. So it cuts x-axis. When y equals 0. So you have 2x minus 1 upon x minus 2 squared equals 0. That means then 2x minus 1 equals 0, or x minus 2 equals 0. So the curve meets the curve. So we have an x equals a half, or then x equals 2. So it's the coordinates, again they highlight that. So it's going to be a half, 0, of course, because it's where it hits the x-axis, and it's then going to be 2, 0. Incidentally, because that's a square, it just means it touches it as opposed to kind of crosses, but that's okay. Write down the coordinates of the point where the curve meets the y-axis. So it cuts the y-axis then whenever x equals 0, and so we need to sub then 0 into this. So y equals 2x minus 1 x minus 2 all squared. So if I sub in 0 here, I get minus 1 here. You could multiply the whole thing out. You might feel more comfortable doing that. And then minus 2 squared is then going to be 4. And so that's then going to be minus 4. So that's going to be the point 0 minus 4. That's quite unusual for one of these questions, but that's okay. So we have those. Expand fully this expression. Okay, so it's going to be 2x minus 1 upon, I'm multiplying this out twice, so hopefully you're okay. Well, let's just write it out actually. X minus 2 upon x minus 2, that gives me 2x minus 1 upon x squared minus 4x plus 4. And again, we've done these now, so we need to multiply everything here by everything here. So the 2x is going to multiply by this, so it's going to give me 2x cubed, then 2x times the minus 4x, that's minus 8 x squared plus 8x, and then multiply by minus 1, that gives me minus x squared plus 4x, and then that's going to be minus 4. If we join these together, we get 2x cubed minus 9x squared plus 12x minus 4. Find the coordinates of the turning points of the curve. Yep, we're heading that way, so we need to find then dy by the x. I'll get you up this expression in a second. So let's make sure we know what's going on here. This was our original, and we've multiplied out this bit. That was the last thing we did, and we have that. So if we let y equal that, then to differentiate that, then we just differentiate each of those terms. We'll kind of keep it above here so we can see, remembering we're letting y equals this, so y equals this. So to differentiate this, then we're going to get 6x squared minus 18x, and that's plus 12. To find a turning point, we put dy by the x equal to 0. So that means 6x squared minus 18x plus 12 equals 0, because it's now an equation we can divide by 6. X squared minus 3x plus 2 equals 0. And that's going to factorize nicely for us, I hope. Minus 1 and minus 2. And let me see, so that means we get x equals 1 and x equals 2. Find the coordinates of the turning point, so we need to substitute this into y equals, I've lost it again, haven't I? 2x cubed minus 9x squared plus 12x minus 4. If I substitute 1 into here, I'm not going to do it now, but if you're substituting the number 1 into this, 2 times 1 and so on, and you work it out. So substitute 1, you get y is 1. If you substitute 2 into this, so again, it's you cube the 2 there, you get 8 times, that'll give me 16 minus 9 times the 4, and so on. You actually get y is 0, which we sort of knew already. That means the turning points happen at 1, 1 and 2, 0. Using calculus, identify each point as either a maximum or a minimum. You must show working to justify your answer. So how do we do that? We need to differentiate that again. So there's the thing we have. So we're going to then find d2y by dx squared. That gives me then 12x minus 18. My 2 points. If x is 1, d2y by dx squared. If x is 1, that's easy. That gives me 12 minus 18. So it's negative is all we need. Therefore, that means it's a maximum. If x is 2, then d2y by dx squared, that gives me 24, take away 18. That's a positive. Therefore, it's a minimum. Using calculus to identify each one, so that's okay. So 1, 1 is a max, and then 2, 0 is a minimum. Hence, using the answers from parts 1 to 5, sketch the curve on the axis below. Goodness me, so we have a lot to do here. So first of all, our turning points, and then 2, 0. Right, let's go back. Excuse me. So we're looking for some sort of cubic curve. So first of all, it cuts the x-axis at a half and 2. So if we go for a 1 there and a 2 there, 1, 2, that should be okay. So my half is here, so it cuts here and it cuts here. It crosses the y-axis at -4. Let's go for that there. The turning points then happen at 1, 1 and 2, 0. So there's 1, 1 and 2, 0. So look at that, see where that touches actually, so that's why then that one just touches. So we're going to sketch this curve now. Hopefully you can see that's going through. There's our maximum there, and then there's our minimum there, and it then heads up that direction there. That's us for that question. Question 13. John took out an investment 20 years ago. Over the next 20 years, he recorded the value of his investment at various times. The table below shows the value of his investment v in pounds after t years. It is believed that the relationship of the form v equals excuse me, at to the n exists between years 3 and years 20. That's why we have them here, where n so our constants verify the relationship of the form v equals at to the n exists by drawing a suitable straight line graph on the grid opposite. So clearly the values used correct the 3 decimal places in the table above. So we're going to have to do log t here, and we're going to have to do then log v here. Taking our v equals a to the t, sorry, at to the n, taking logs of both sides, we have log v equals log a t to the n. That means log v equals log t to the n plus log a. I've sort of rearranged there, I hope that's okay. Hopefully you're reasonably used to these. And log t plus log a, and that's going to look a bit like y equals mx plus c. So we're going to use that then to work out some of the bits and pieces then that we need a little bit later on. Using log t then, so I'm going to do log of 3. That's 0.477. If I do the same then for the other ones, I get 0.699, 0.903, 1.146 and 1.301. Log 673.14, that gives me 2.828, 2.855, 2.879, 2.908 and 2.927. get a few marks in for that. So we need to then fill in our table. So we need to label it first of all. It's going along the bottom because a log t is a bit like our x. So this is going to be our log t going along here. You'll get a mark for this. Log t, and here we're going to have log v. And our first point we're trying to plot then is 0.477 and 2.828. So it's 0.4, that'll be 0.46, 0.477 and 0.82. So there's 81, so there's 82 there. So 0.281, 282, 283, 284. So it's 282, and it's quite close into the 3. So we're going to be up this direction here, and it's 0.477, so we're quite close into that. So we're going to be in and around there. Our next point is 0.699, so that's really as close to 0.7 as you're going to get, and it's 2.855. So 2.8, that will be 2.855 there, so you're effectively going to be on there. Next one is 0.903 and 2.879. There's 2.85, 2.86, 2.87, 2.879. So we're just there about there. 1.146. So 1.14. It's going to be round about here. And then that's 2.908. So again, I think in round about here. And our final point then is 1.301. So pretty much on the 1.3. And it's 2.92, so there's 2.90, 2.91, 2.92, that's 2.927, so we're in and around there. So we can see that that gives us a straight line, therefore our relationship is verified. Fabulous news. And we end up then with something like that. Hence, find the values of a and n, giving a correct to the nearest integer and n correct to 2 decimal places. Well, our value, first of all, of n is going to be our gradient. And the way we work out our gradient is we maybe don't go back to this graph here. We're probably going to take these 2 coordinates here and the y and x values in for those. So our gradient, so you can see this okay, gradient, which equals n, is going to be y2, which is 2.927. See where I'm getting that from the table, not from the graph, minus 2.828. That's all over 1.301 minus 0.477. Again, stick that into your calculator, you will get 0.120. So we're going then for 0.12. Couple of different ways then to work out the a. I'm going to go this way. V equals a t to the power of n, and I'm going to take values that I know. So actually, because it's the v and the t, it's not the log v and log t, so I'm going to take these ones here. So my t value is 3 and my v value is 673.14. So 673.14 equals a upon 3 to the power of 0.120. That gives me 673.14, 3 to the power of 0.120, 3 to the power of 0.120, and that gives me 1.141, 1.141a. So my a value then is 673.14 divided by 1.141, and that gives me something like 589.956. It asked me to give it to the nearest integer, so we're going to go then with 590. So my value of a is 590, and my value of n then is 0.12. That's it, correct down to 2 decimal places, as you know. Use the formula v equals at to the n with your answers of n to calculate after how many years the value of the investment was 830. Give your answer correct to 1 decimal place. So we want to know when this value is 830. So it's v equals at to the power of n. So it's 830 equals 590. That was my value I got for a, t to the power of 0.12. So we then need to divide by 830 by 9. 830 by 590 equals t to the power of 0.12. Again, you can do logs of both sides here or whatever you want, but I'm going to do the power of 1 over. Say you had t cubed there, I'd have to put this to the power of a third. If you have t to the power of 4, I'd have to do this to the power of a quarter. So I have the 0.12, so I'm going to go to the power of 1 over 0.12. So it's 830 over 590 to the power of 1 over 0.12. Again, I hope you've seen something like that before. And if you put that in your calculator, you'll get 17.2. We have that. I think we are on to the final question. On a remote island, the population P of lizards is modelled by the function, where T is the time and month since counting the lizards began. A sketch of the population of lizards against time and month is shown below. We have that. Write down the initial population. Well, obviously initial population, that means whenever T is 0, if we put T equal to 0 into this, we obviously get P equals 10. So it's 10 lizards. Using calculus, find the time and months after which the population started to fall. So you can see it's rising, and here then it starts to fall. So we need to find that. So we're going to use calculus and find then the kind of maximum by putting the gradient equal to 0. So we're differentiating this. Normally it's y and x, it's dy by dx. So we're going to go dp by dt. So there you can see the function above, and I'm going to go then dp by dt. That gives me 3t squared minus 24t plus 45. We want to know kind of where the turning point is. So at turning point dp by dt equals 0. So that means 3t squared minus 24t plus 45 equals 0. Because it's equal to 0, we can now divide by 3. T squared minus 8t plus 15 is 0, and that factorizes for us. So we get t minus 3 and t minus 5. That gives us a value of t equals 3, or t equals 5. Now, I'm reasonably suspicious that this is 3 and this is 5, so I assume then my answer is going to be there, but obviously we need to kind of prove that, so we need to do a wee bit more and find d2p by dt squared. So d2p by dt squared, so differentiating this again gives me 6t take away 24. Whenever t is 3, d2p by dt squared is a negative, so it's minus 6, therefore then it's a maximum. And so my answer then is, so it's after 3 months. So 3 is a right answer because that's our maximum, so then it's after 3 months. Nothing on this page. What is a minimum number of lizards after the population started to fall before it began to rise again? So that's saying whenever t is 5. So when t is 5, again, let's do our check. d2p by dt squared. That gives me 6. Let me see if I can find this page for you here again. 6 times 5 is obviously 30, take 24. Which is 6. 6 is a famous positive number, therefore it's a minimum. So whenever t is 5, I'm going to substitute this into p equals, again, I'm searching for our question. There it is. t cubed minus 12t squared plus 45t plus 10. P equals, so 5 cubed is 125. 5 squared is 25, so that's going to be, it's 300, isn't it? 300, and then 45 times 5, 180, 225, I think, plus 225 plus 10. Whatever way it works out, it should come out then to be 60. Hopefully I've got that right. And so my answer then is 60 lizards. And that's us.